Factoring. Woohoo! Okay, so we're going to start with the first thing you should always look for when factoring an expression. And notice we're factoring expressions, not equations. What's the difference between those two statements? What's the difference between an expression versus an equation?
An equation is when something is equal to another thing.
Correct. An equation has an equal sign. An expression
Doesn't.
doesn't. Good. What do you do with an equation?
You try to solve for the variable.
Good. Solve. What do you do with an expression?
You factor or something.
That's part of this big thing that you do with an expression. No, you can't talk. You retarded. Simplify. You simplify expressions, you solve equations. We are simplifying equations. Sorry. We're simplifying expressions first, and then later we're going to write them as equations, and then we'll solve equations. My point being, as we work through this stuff, don't magically make equal signs appear out of nowhere. There are no equal signs here. Okay? So we'll start with something simple, like the following. And we want to factor this. And so in order to factor this, some new shoes?
No, I just haven't worn them.
Those are awesome.
Raise them up.
She's got some 10-hole white Doc Martens. Anybody Doc Marten fan? I have like 6 pairs at home. I love them. They're so comfortable.
Are they squeaky?
A little bit.
Yeah, sometimes they squeak.
Yeah.
Really distracting.
Well, that sounds like a challenge. Well, I'll be doing some experiments later to see what I can add to my shoes to make them squeaky. Oh, I stepped on something. Like cutting up the floor over here. What was I talking about?
Shoes.
Fuck.
Wow, you're all
Oh, yeah, I'm easily distracted today. Okay, first things first, before you try anything that you may have learned, like doing the whole 2 parentheses thing, does anybody do the whole fishy, boxy thing? Good, I'm not going there. Never mind. Forget I even mentioned it. First thing you always do, number 1, is what?
Create a common factor.
Beautiful. GCF. And you will forget that, and you will be upset with yourself when you try to factor a big, scary expression, and you realize that if you would have just factored out the GCF, your life would be so much easier. So in this particular example, what is the GCF between those 2 terms?
7x.
7x. So we're going to take out a 7x. If I take a 7x out of a 7x squared, what do I leave behind? X. And if I take a 7x out of a 21x, I'm left with 3. So what's x equal? Good. Trick question. It doesn't equal anything because there's no equal sign. Don't make one magically appear. Sometimes in a problem like that, well, scratch that. Let me start over. Can I factor that anymore? No. So sometimes when you factor out a GCF, that's all you need. You're done. Sometimes, however, it will get a little bit more complicated, and we'll get to some of those in a second. However, let's look at this guy. By the way, what is the fancy mathematical term for this kind of expression? Nobody? Nobody. Molly? You're up.
I'm quite unsure.
Hold on.
Let's play some Hangman.
Shh. Molly. And Molly only. Go.
Hey.
A, as in aardvark.
Yes.
Good guess to start.
I.
As in iguana.
C.
C? C as in Spanish, yes, or C as in the next letter you're guessing?
Spanish, yes.
Oh, you're very confusing.
S.
S as in salamander.
Yes. Rat. T.
T as in turtle.
E.
E as in elephant. By the way, we're playing old school here. Head, body, 2 arms, 2 legs. We're not putting shoes on and 5 fingers on each hand and a glove and then a scarf. Hair. Right.
C.
C as in kangaroo.
No.
What?
No?
I don't even. That's K.
Oh,
C
right,
is
right, right.
cat.
That's why I went into math. What? C as in cat. Good. Okay. Shh, you be quiet. Your name isn't
I don't hear
Molly.
anything.
That's good, I know.
Q.
You're not a cheater. Or a pumpkin eater. I'm sorry?
Q.
Q. Well, that's an interesting guess.
Whoa.
Quadratic. Woo! I hope I spelled it right. Yeah, I did. Good.
Why is it just quadratic?
It's not plural. There's only one of them. Well, there are 2 now, but initially I was just asking about the first term. So this is a quadratic. Molly, what makes it a quadratic? Other than that was a solution to the hangman puzzle.
It has 4 parts.
Nope. It's a good guess though. Quadratic, quad, 4.
I was trying for it.
I understand. Nicole?
Because of the exponent,
So,
it makes it quadratic.
which exponent?
The one on the first term, 7x squared.
The 2?
Yes.
Correct. That's called the degree, by the way. The degree is the highest exponent in the expression. And if the degree is 2, then it's a quadratic. Now, excuse me, no. This is a quadratic that has 2 terms. The terms are the things that are separated by pluses and minuses. First term, second term. 3 terms here. What is this thing called?
A trinomial.
No. Oh, yes, correct. It is a trinomial. What kind of trinomial?
Oh, I know.
I'm sorry, I have to call on him now. Just so he calms down. Yes,
A
Emmett.
perfect square trinomial.
That is incorrect.
That was like
That'll come later, though.
everything last year. Like, the answer is perfect.
What kind of trinomial is that? Paul? Wait, you can't talk today. I forgot.
I got this now.
Go ahead, Mary.
Quadratic.
It is a quadratic trinomial. So, quadratic,
Binomial.
binomial, quadratic, trinomial. So when we're factoring trinomials, we have a whole process to do that. What's the first thing I should check?
Greatest common factor.
Don't even raise your hand anymore, Paul. I'm not going to call on you. Is there any GCF in these 3 terms?
No.
Nope, so we move on. Now, I don't know how you've learned it and what process you've gone through. Some people teach something called fishy, or they do the same thing and call it boxy, or whatever. We're not going there. I like the tried and true method of breaking it into 2 parentheses. Oh, excellent. A vote of confidence. Let's look at the first term. What 2 things multiplied together give you x squared? Seems like a silly question. Mary? X and x. Is there any other 2 things that can multiply together to give you x squared?
No.
Trick question. You could do x squared in 1, but that would be ridiculous. Yeah. Okay. Now, the other 2 spots have to be filled by 2 numbers that when multiplied together they equal -6, but when added together they equal -1. Good. So what 2 numbers multiply together to give you -6 and add together to give you -1?
-3 and +2.
Whoops, -3 and +2. Okay, let's suppose this is a quiz question and I got 10 minutes left and I finished already and I want to make sure that that problem is correct. How could I check to be sure that that's correct, Madam? Foil that puppy out. We're not going to, but you could, if you had to, foil it out. And I assume you're all familiar with foil.
Yeah. First, I'll take it.
Outstanding. So we won't even bother with it. Next question. Can these be factored anymore? No. Done. Okay? Good. Let's move on. Easy peasy.
Lemon squeezy.
You try. Okay, so we'll call this number 1. We'll call this number 2. We'll call this number 3. You do this one on your own.
We do that on our own.
Factor that. Check with your neighbors.
Divided on plus 5.
Grace, what do you got?
X plus 2 and x plus 5.
How'd she do?
Good.
We're all in agreement?
Yeah.
Excellent. No problems, right? Okay, good. How can we make the problem more interesting? Usually interesting translates into more difficult. Yeah, that's right. Don't even raise that hand. Leave it down. What if we do something, well, hold on. Before we make things more interesting, let's do another practice one. Factor this. Michael, what do you got?
X minus 3 and x minus 3.
How do you do?
Good.
Now, seeing as this is an advanced honors class, how can we write this to show off?
X minus 3 squared.
Good. All right, we solid? Good. Let's make it more interesting. What number are we on? 5?
Yeah.
Okay. Ooh, color change. Let's do this one. Go ahead. I should know what that wrestling is by now. It's everybody reach for their calculators. If you rattled off 5 right away, then you can chew on number 6 for a second. Anybody got an answer for 5? Still working? Oh, you know what the problem is? Sorry. That might help.
I was like, how do you do that?
Okay, wait, hold on. Let's go back. So, Vanessa, you just said, how do you do that, right? What happens when it doesn't factor? What if this doesn't break down?
Oh, it's 72? Prime.
That's later. What do you call it when it doesn't factor?
Prime.
It's prime, right? Okay, so I meant to write 15. I missed a number. Now it should factor. This one, however, to save some time, this one is prime. There's no two numbers that multiply together to give you negative, or to give you positive 7 and add together to give you negative 5. So it's prime, meaning it doesn't factor. You can still solve it probably. We're just going to learn that later. Hopefully that'll help and make it a little bit more doable. Ben, what'd you do first? I know you're still working, but
I divided the whole problem or equation by 3.
good. Factor out of GCF.
Oh, well that.
That might make it a little bit easier. What is it?
24.
Thank you. I didn't want to show off. Oh yeah.
So 24 actually is 24.
Just 24. Yeah. Question?
No, I just know the answer. Oh wait, as long as I have one.
Is that what you have for an answer though?
Yeah.
Good job. Yeah. Be careful on the signs. Make sure you know which sign goes to which. Okay, can we move on? Questions? No. Okay, let's look at a couple other scenarios. We have something that looks like, what are we on, 8?
7.
No, it wasn't 7 over?
No.
That was 6?
Yes.
So now we're on 7. I do know that 7 comes after 6. You'll notice the first problem we looked at had 2 terms, and all it was a GCF. This last couple that we've looked at have been 3 terms, or trinomials, and they factored using the parentheses. This one is 2 terms. And yes, Evan?
Yeah.
You were just waving your hands in the air like you just don't care? Or were you raising your hand for Paul?
No, I accidentally just put the hand.
You've got to be careful when that happens. If you're in a large group and somebody says, who wants a punch in the face? Your hand just accidentally flies out. That would be bad. Did you want to answer a question that you thought I was going to ask?
Yeah.
Okay. I can't wait to hear this. Yes, Mary?
Can I take a guess?
On what?
Second.
You want to
what
take?
it is.
You want to? What
Like
it?
what it's called.
What's what called? That? What's that called? All right. What is it called?
Wait, now you're scaring me. Okay. Okay. Can I just guess? It's like the difference of squares.
It is called the difference of squares. Correct. Well done. If there's 2 terms, and both of those terms are perfect squares, and it's a subtraction problem, not addition, then it will factor nicely. Mary, do you know how it factors?
Yeah. Is it like? Dang. X plus and like.
Is it like dang? Depends on your definition of dang.
X plus something and then X minus something. Goodbye. X plus 7, X
Oh.
minus
Oh, wait, sorry, my bad. You think it's what now?
X plus 7 and X minus 7.
Good. Okay. You will do this a lot, not only in this class, but my calculus students do this numerous times per day. Recognizing the difference of perfect squares. The easiest way to think of this is take the square root of the first term. What's the square root of x squared? X minus the square root of the second term. Square root of the first term plus square root of the second term. You're done. Okay. This does not factor. When it's the sum of squares, that's always prime. So we're not going to deal with that. That doesn't work.
Are you gonna put that on a test?
You never know. Yep. Okay, so two terms you have to look at. First, again, GCF. And then secondly, if that's the difference of perfect squares. There is also a difference of triples, or of cubes, but we're not going to do that. Because that would make your head melt. We'll save that for a later date. Okay, last example, number 8. There are two ways to do this. I'll be intrigued to see which method you use. By the way, on a homework or a quiz or a test, the directions for these types of problems would say factor completely. Okay, two approaches to this problem. They're both correct. One of them is more corrector, because what's the first thing you always do?
GCF.
GCF, but the GCF here is 4. Then this is x squared a perfect square.
Yes.
Is 9 a perfect square?
Yes. Difference of squares.
Thank you, Emmett.
A little too late.
It's good to know you got my back. However, walking around the room, I did see a couple people do it differently. Is 4x squared a perfect square?
Yeah.
What's the square root of 4x squared?
Yes.
2x. Is 36 a perfect square?
Yes.
Square root is?
6.
These are different. How do you resolve that? You got to take a 2 out of each of these because this isn't factored completely. So pull a 2 out of the first one. Whoops. Whoops. Let's get the old eraser going here. Just taking that for a test run. 2 times x minus 3. 2 times x plus 3. 2 times 2 is 4. Oh, look, the same answer. Yay! Same. Which one is more corrector? The first one, because you're supposed to factor out a GCF every single time.